We're going to look now at how the position of the centre of gravity of the vessel has a direct bearing on its ability to right itself. And we're talking about vessels inclined by an external force, and we're going to look at three stages. We're going to look at a stable vessel, a vessel in neutral stability, and a vessel that's unstable. And what I've done initially, I've done a sketch, and you can see that at the moment the sketch is exactly the same for all three stages. The only letter that's missing at the moment is G, well GZ, but the centre of gravity is missing. So you'll be expected to do this drawing, and it does come up quite a lot in SQA exams. And the condition they could ask you to draw it could be stable, neutral or unstable. So this just points out that it's basically the same sketch, just with the position of the centre of gravity changing. And just to quickly recap, that was our original drawing that we looked at, and we had our GZ there, which is our righting lever. Okay, so with a vessel that's stable, it would follow really that the centre of gravity is going to be fairly low down, because if you think of a vessel, if you've got lots of cargo on and it's very low in the lower hulls, it's a very stable vessel. It rolls very jerkily, but it's very stable because all the weight's at the bottom. Much the same as if you're in a car and driving along and you put all the weight at the bottom of the car, it's a very stable car. If you put all your suitcases on top, on a roof rack, over to one side, or just simply all on top, then it's going to be potentially unstable. So it's the same with a vessel. So we'll put G here, our centre of gravity, and the perpendicular distance between the two creates GZ, or our righting lever. And you can see there with a stable vessel, G is low down and you have a large righting lever. And because that's a large size, multiply that by the displacement of the vessel, and it stands to reason that more moments are being created. And because more moments are created, the vessel will right itself very quickly. So this vessel's stable. In fact, the vessel would be stable moving G all the way up. So you could have G in this position here, it would still be stable, but you can see that GZ, or the righting lever, is becoming smaller. Go up to here as well, GZ, it's still a stable vessel, but you can see that the size of GZ is decreasing all the time, and obviously the GM of the vessel, the size of the GM of the vessel is decreasing. So that then is an indication, if your GM is decreasing, your metacentric height, your GM, then your stability is decreasing as well. So that's the vessel that's stable, and we can put G in several positions. Now let's move on and look at a vessel that's in what we call neutral stability. Now neutral is when G and M are in the same position. So the centre of gravity has moved up, and it's got to this position here, and you can see that GZ has to be 0. There can't be a righting lever because there's no perpendicular distance between a buoyancy and gravity force. Well, what happens to that vessel when she's at sea? Well, as she's heeled over due to an external force, then another external force will bring the vessel back. So she'll roll over very gently and then very gently roll back. Obviously not a good position to be in. So with neutral stability, G and M are in the same position, and effectively you've no righting lever. Okay, let's move now to the third stage, which is what we call unstable vessel. Well, an unstable vessel is where G has moved steadily up, or the kg has increased, or the GM has decreased, whichever way you want to say, and there's M there. G has moved up, and G has now gone above the metacentre. Okay, and in that instance then, what's happened is that our righting lever from a vessel being stable has become a capsizing lever when the vessel is unstable. So when the vessel heels over, instead of the vessel having a lever that rights itself, basically it becomes a capsizing lever, because you've got this weight force acting now vertically down from there. You can see there. and that creates a very difficult situation. It's one that you certainly don't want to be in. So when we started out with the 3 sketches, they're all identical except we didn't have the position of the centre of gravity on any of them. And with stable vessels, G is below M. Very stable is the further down, and it becomes less stable as it goes up. But nevertheless, it is stable, and you've got positive GM. Then we have neutral stability, where G and M are together, and effectively you've no righting lever, GZ is 0. And then we move to most unsatisfactory situation, unstable, where G has moved above M, and the righting lever has become a capsizing lever. So they're the 3 stages that you would be expected to sketch proficiently and explain as well, any of those 3.